Here it is third problem. I'll read the problem. At 1100 Kelvin, the following data were obtained on homogeneous reaction. This is the reaction. It is homogeneous reaction. The data. Look at the data. What is data? It's again the same problem. We are going to find out overall order and rate law and rate constant and rate of this particular concentration. So these are the data that is obtained from an experiment. So you are carrying out this reaction, and you have measured the rate of this reaction when you are taking at different concentrations, right? This is the experimental the experiment that you have carried out, and this is the observation. This is the rate that you observed from this experiment. So you just look at it, you'll understand. It's very simple. So here nitric oxide, here you have taken nitric oxide and the hydrogen is reacting and gives you water molecule. That's all. A simple reaction. Here the nitric oxide concentration is given here, hydrogen concentration is given here, and the corresponding rate is given here. The first experiment that you are doing is you have taken 5 in 10 power minus 3 mole per decimeter cube of nitric oxide, and you have taken 2.5 into 10 power minus 3 mole per decimeter cube of hydrogen. So this is the concentration of nitric oxide, this is the concentration of hydrogen that I have taken, and then rate is, I have measured, the rate is 3 into 10 power minus 5, right? So this is the first experiment, and then the second I have done, I have taken 15 into 10 power minus 3 mole per decimeter cube of nitric oxide, and the same amount of hydrogen is taken. Now the rate is actually 3 times increasing, right? This is 3 into 10 power minus 5, this is 9 into 10 power minus 5. Here this is your initially for the in the first experiment the rate is 3, and what you are doing is you are increasing the concentration of NO. The concentration is 3 times you are increasing. Since you are 3 times you are increasing the concentration of NO in the second experiment, here the rate is 3 times are actually increasing, 3 to 9, so 3 times rate is also increasing, but you are not changing you are not changing the concentration of hydrogen. And then now I have kept the same concentration as of the second experiment. I have not changed the concentration of NO, but I have increased 4 times. I have increased 4 times the concentration of H2. Now look at it. It is also 4 times 9 becomes 36. That is 4 times 9 into 4 36. 9 into 4 times is 36. So 36 4 times are increasing. So if I increase the concentration of hydrogen 4 times, then the concentration, the rate is actually increases by 4 times. Here I have not changed the concentration, right? Here I have increased the concentration of NO by 3 times. Here I observed the rate is actually increased by 9 times. This is how you have to analyze the given data. So they are asking you to calculate overall order of the reaction. See, just by looking at these data directly, you can say the overall order and order with respect to NO and order with respect to H2, because we have analyzed the data. That is, when you increase the concentration of NO 3 times, the rate is increasing. The rate is also increasing 3 times. When you increase the concentration of H2, keeping the other reactant NO concentration constant, increasing the concentration of H2 4 times, the rate of reaction increases 4 times. So what do you mean by that? You just write solution. It's very simple solution, right? For the first, I said, um, let me write the general rate equation. K, this is NO power, I don't know the order, and this is H2 power N, I don't know the order, right? Then in the first case, if I increase 3 times, three times of NO power M, rate is increasing by 3. Right? Rate is increasing by 3. This is H2 power N. That means if the value of M is given 1, then you will observe this change. When the value is 1, then this is true, that the rate will increase 3 times. 3 into K NO power 1 and H2 power N. So this is the rate will be 3 times of rate. That is 3. This is actually rate expression, rate. So the rate will increase 3 times when M is 1. So therefore, when M is 1, M equal to 1, rate is increasing to 3 times. Okay, that's all. So with respect to N, can you say the number N? I'll say rate is now becomes 4 times. Rate is becomes 4 times. Rate is become 4 times when K NO power M and rate is becomes 4 times of, we are increasing the concentration 4 times. 4 times of H2, then you should observe the rate is actually 4 times increasing. So this N value is supposed to be 1. Therefore, N value must be 1. When N is 1, this is true only when N is 1. When N is 1, the rate will increase 4 times. If N is 2, if you increase 4 times the concentration of H2, what will happen? 4 power 2, 16 times. The rate would have increased to 16 times. But this is not your experimental observation. Your experimental observation is only 4 times increasing. The rate is increasing only by 4 times. When you increase 4 times of hydrogen concentration. So N value is supposed to be 1. It is not 0, it is not 2, it is not 3, it is not any other value. The rate, if the experimental observation should be obeyed, this is true only when N equal to 1. So therefore I can write it is 4 times of rate. 4 times of rate. So therefore I found for the first question, calculate overall order of the reaction. What is overall order? And let me write rate equation. Rate equal to K times NO power m power 1, I found it is n NO power m equal to 1, and with respect to hydrogen is 1. So overall rate equal to 1 plus 1 to 2. That's all. This is second order reaction. I found it a second order reaction, and with respect to NO, order is 1, and with respect to hydrogen, order is 1. Therefore this is a second order reaction. What is the other question? The second question is, write the rate law. So this is rate law. Third question is, calculate the rate constant. Calculate the rate constant value. How will you calculate? You take rate. You'll take any one of the data. I'll take the first data. That rate is 3 into 10 power minus 5. They are asking as to calculate the rate constant. They are asking this value. NO concentration is 5 times 10 power minus 3. Just now I found power 1, and the H2 it is 2.5 into 10 power minus 3 power 1. So here 3 into 10 power minus 5 K, this is 5 times 2.5, it's 1, therefore 10 point, sorry, it will be 12.5, right? 4 times of 2.5 is 10, 5 times of 2.5 will be 12.5. 12.5, this is power 1, so no problem. This is 10 power minus 6, so K equal to 3 into 10 power minus 5 divided by 12.5 into 10 power minus 6. This is, so you have to divide it. We say 30 is divided by 125. This is 0.0, and then 2 times, right? 2 times. Okay, then if you subtract, you'll have 50. Then you just 0. Then it becomes 4 times, right? 4 times, yes. Yes, 0. So if I divide, then this is 0.24 into 10. So this is 2.4. So the K value is 2.4. That's all. 2.4. I found it is second order reaction. What is the rate constant unit for second order reaction? It is decimeter power 6, mole power minus 3, and this is, they have given it is second. So second inverse is the rate constant. So this is the rate constant value. Okay, then fourth, what will be the rate of the reaction? So fourth is, if NO and H2, their concentration is 8 into 10 power minus 3. So they are asking you to calculate rate equal to K is 2.4 for this reaction. For this reaction at this temperature, this is actually your understanding. When you are solving the problem, you can understand thoroughly your concepts when you are solving a problem, right? So this is a rate constant of this reaction at 1100 Kelvin. And the fourth question is they are asking you to calculate rate of reaction. So rate is rate constant times concentration of NO and concentration of H2. Concentration of NO and concentration of H2 is equal to 8 into 10 power minus 3, and this is 8 into 10 power minus 3. This is 2.4, 8 into 8, 64 into 10 power minus 6. 2.4 times 64 will be 2 times of 64 is 128, and the 0.4 times that is, I take it as 0.5, approximately 5. 5 times of 64 is half of it. Half of it is actually 32. 32 is 32. So 8, 10. Okay, then 6, 1. So it's about 160. It's about 160 into 10 power minus 6. It is about 160 into 10 power minus 6. It is approximate value. You can use your calculator. Therefore it is, I can write 1.6 into 10 power minus 4. This is the rate of this particular reactions when you take NO and H2 concentration into 8 into 10 power minus 3. So that's all. And look at this problem. This is the same type of problem. I'm not going to solve this problem. You look at the data. A simple reaction. The concentration of A is given, concentration of B is given, and the corresponding rate is measured. They're asking to calculate the order with respect to A and B, and overall order, and rate law, and the rate constant. That's all. How will you analyze? How will you analyze the data? The concentration, in the first reaction, the concentration is 6, and here is 1. The rate is 0.012. You have doubled the concentration of B, but concentration of A is same. So if you double you are doubling, rate is also doubled. So when you double the concentration of B, rate is doubled. Here when you double the concentration of A, you are not changing the concentration of B, but here 4 times, right? 4 times increasing. The rate is 4 times increasing, and then this is how you have to analyze this data, and then find the order by yourself, and we will discuss it if you have any doubt in online class. Okay, then